Welcome to Tech at Lunch, the podcast that satisfies your hunger for all things tech while you enjoy your midday meal. So grab your sandwich, tune in, and let's dig in. Hello, I'm Nick.
Hello, I'm Ed.
Hey, I'm John.
And, we're back at it again, and, we're kind of talking about, certain things. We kind of went through last week, and, we kind of had a little bit of fun with that. So, this week, we're going to kind of dive into the world of 3D scanners. And, we're going to kind of look at, just what they are, the different brands that are out there, your typical applications and, stuff like that. And also, it's kind of the stuff that we're looking forward to, because the preface of the, well, I can't speak today. Preface,
You got it right. You got it.
Preference.
There you go. You got it.
All right, I'll get it eventually.
Words are hard.
I swear, freaking English.
Words are hard. This is why we're not English majors.
Right. Going for a doctorate in technology, not English. But is because, yeah, Grammarly.
There it is.
And we looked at it, and I decided to pull the trigger on one of the Revo Point Macaros. I think that's how they're saying it now.
It's the one with the
Morocco
Yeah.
Pros, and we're kind of waiting for that to ship, so we can start playing with it.
What size is so? It's got a scanner. It's got all the cameras and stuff on it. But what size is that screen? It's like a 7-inch, or is that a little?
Something like that.
It might be a little bit smaller than that. 7-inch sounds like a pretty big screen for a handheld, but at the end of the day, most of those cameras, those scanners are pretty large too, where the cameras are at least.
It only weighs 750 grams.
Okay, I thought. Okay, I mean that's not that bad.
No, and the thing is that stuff.
A pound or something, a couple pounds.
Right, not even.
Not much.
But 6-inch. It's a 6-inch.
Yeah, okay, I figured.
2K screen, and it's adjustable.
That's a good resolution though for a tiny. Yeah, that makes sense.
But the thing is, and that's something we want to kind of touch on today is kind of what we did, what we're doing with it, and stuff like that. So, I'll turn it over to y'all. See what y'all think.
So Revo Point has kind of stood out to me since we went to Rapid. I mean, I knew about 3D scanning. I think we should probably take a step back and talk about what we mean by 3D scanning. We're not talking about like a fax machine scan. That's for 2D, but we're taking and adding an extra dimension to that. So,
right.
So the hard part about that is that you're using several cameras to get a bit of depth on whatever you're scanning, but the hardest part about scanning an object is being uniform, or like if you get one angle and then you try to spin it around and get the other side, will those two images or scans match necessarily? So you get some deformation if it's not done right. So for me, I think that the basics, like talking about what a scanner is, what a scanner does, what as a 3D printer, like consumer, prosumer, industrial side, like engineering grade, like what do you expect on that?
Yeah.
Like for me, I would hope to spend $200 at some point on something that's like not too crazy, but again, you pay for the quality, so you would probably get some pixelated. You'd have to do a lot of editing in CAD, which kind of doesn't that defeat the purpose?
Yeah, a little bit.
You're scanning because you don't want to make the CAD file.
And the thing is most of those you see, you can pay $200, $300, $400 for one, especially like Revo Point, for example. And they're affordable. They're nice. However, you have to, walk around a laptop looking like you're daisy chained or something.
Yeah.
All of the, you got the handheld ones. Some of them are like $1,000 for these scanners and stuff like that. But, and yes, it gets, wider area and it's, LiDAR and radar and all this other crud.
Everything has a different feature.
Right. But, being tied to a laptop, the thing is now you're at the cost of the laptop that you have to deal with more RAM, more CPU usage.
No. Well, the one thing I will say is you're not going to get around needing an extra computer.
Right, exactly.
Because
it's just, do you really want a tail?
It's true. It would be nice to have it wireless or some type of storage on the device on an SD card, and I can take that SD card and connect it to the computer and not have to worry about it. But I mean, at the end of the day, like the basics of 3D scanning, the idea, the innovation behind it is good. I think we need to continue thinking and growing like the additive manufacturing world with processes like this.
Mm-hmm.
It's like a juxtaposition of a few different disciplines, right? So you're thinking about, hey, I want to rapidly prototype and scan these like files or whatever objects. How can I get these objects into digital world that I'm building or something like that?
Yeah.
Or print them if that's what you want to do, or replace a part if that's what you want to do. I mean, I picture you have a broken piece, or like let's say you broke a handle off like a cabinet door, and you set both pieces in there. I scan both pieces, and I can put those back together on a CAD, reprint that file, and have that back and completed.
Yeah.
It can be kind of a way that if a part's not manufactured anymore, you can get that back, or at least as close as you can, without having to model the file.
Yeah.
Now,
Anybody with a collector car will understand that one.
yeah, I think that there's definitely a line though of where it's like efficiency goes down with the quality of the cameras. Like if it doesn't have, if you don't have a good camera, you're gonna get a very, it's like distorted or like minimalist. It's I don't know if anybody who works with 3D models or like 3D meshes and modeling or animation, polygons. You talk about how many polygons are on a structure, because that's how you can better. It's like pixels on a screen. If you have more pixels, you have more polygons. It's more. You can see better what the object is.
Right.
So it's more precise. If I have a bunch of polygons, why didn't I just make it myself? If it's very like minimalist, why didn't I just make that myself in a CAD Blender or Fusion 360? I don't know.
Me and Ed saw one. Remember the one at up in Greenville that was on the end of the robot arm?
Oh, that scanner on there?
Yeah, it was from Zeiss,
Oh, okay.
and it was on the end of a robot arm. And it was scanning auto parts,
So
stuff like that. Yeah.
I like that because it's a lot more controlled than me, who doesn't have a steady hand trying to hold this scanner.
Drink more coffee.
Yeah, I mean, no. Coffee just makes the shake faster, right?
Eventually, it'll offset itself.
Yeah, right. Little bit. No.
So I would say here's another way to look at it. For example, and I'll just touch on it and we'll come back around to it. So far as a $200 scanner versus a $1,000 scanner, it depends on what you're talking about. With the advent of AI and Midjourney and stuff like that, there are possibilities to take any image and clean that image up with
That's fair.
no
Yeah,
inputting into
that's fair.
inputting to any software. That's where we're going. And if that's where we're going, then we should be able to take any image, clean the image up through some type of filter, whether we program it ourselves with some library from Python or some library from whatever software you want to use, C Sharp, or if you want to use C++, whatever, whatever is your flavor. You can write something to post-process the image. The rest of it, as far as converting it over to whatever you want to, once again, I can make post-process things to work in conjunction with the scanner. So we'll come back around to it, because this is just okay. Hey, how about using it this way?
Makes sense.
Okay, but let's talk about some of the types. So, we got laser triangulation, and that's basically where we project millions of dots per second to make measurements.
Okay.
Then we got structured light scanners, to use white light or blue light, kind of like a projector with two cameras at angles on either side. Then we have like depth sensing cameras. Again, they use field of dots, but with infrared.
Okay.
And then for photogrammetry, that's like more precise measurements of photographs. And then we got LiDAR. So we talked about LiDAR, so they're different types of mechanism we're using to do this. So I think the cost point will come down.
Yeah, so and that makes sense. A lot of stuff, as the chips we make are, smaller and smaller, easier to make, and whatever the case is, things, electronics have tended to go down in price, but I think that it makes a good point. The list of the cameras that you use, I'm thinking about the quality of that camera, but I don't think that you can stop at just the quality of the camera, because I think, I mean, all our phones are getting better with cameras as well.
Yeah.
So there's bound to be an app. There is an app. If you have an Apple, I know there's Android apps as well, but I'm not sure of the names. But for Apple, there's Polycam. It works really well, and it hinges on the lidar of the newest iPhone. So it's using that higher level of scanning or ability to low light detection is really what it is.
Right.
But it makes me think, and it raises a lot of questions for me. And I don't know if you guys have thought about these things either. But so scanning anything, if you're using white light or if you're using like dots, we're talking light waves or lasers, right? So when you think about wavelengths, like when you think about color spectrum that comes from waves, black is technically what's absorbing those wavelengths. So like if this camera's trying to bounce off of the object and kind of take a picture or take a reading of what the object is, I think that any object that's a dark object or honestly like a closer to like a true black or a high contrast, you're gonna lose some of that.
Yeah, the absorption.
Except you mentioned it earlier, infrared. That's kind of one of the ways that might be a little bit easier. You have a different wavelength, but if we're talking the visible light spectrum, this is. I mean, I haven't proven anything because I haven't used any scanners, but I strongly believe that the difficulties we have with lower quality scanners is directly proportional to how it deals with some of that light waves.
Makes sense.
And I mean, it's the depth that it's trying to get, so that makes sense. But yeah, I have a iPhone 13, and it can't do anything like what they would be doing with the iPhone 14. So for me, I think it makes sense. They're trying to be the Swiss Army knife, like the tool or the phone that's your Walkman, your phone, your calculator. They're just
Your
absorbing.
Nextel,
It's become your computer, your personal computer. You're looking up things on the websites. But I'm thinking it's pulling in more usability because people are already using them for photography.
Right.
They're using them to shoot videos and things like that. So
I like the idea, honestly, but I guess I could say I'm a purist. I like to have a dedicated device for most things because I do better with a dedicated device because dedicated devices are designed for that only.
Yeah.
Like I was looking at the one I ordered, the Morocco. The technology on board that thing is the quad camera infrared structured light. So it's quad camera and it's infrared.
I thought it had LiDAR as well.
I might have some version of there
It's
in
got
there.
like 4 cameras, doesn't it?
Yeah, it's 4. It's auxiliary lighting is infrared fill lights and flash LEDs.
Okay.
So it's the 3D light source is a class 1 infrared light.
Okay.
And this has kind of led me down. This is when you start playing the hypothesis game and you start really seeing exactly what type of Weird Al Yankovic thing you're heading. Is the fact of does outside light cause any issue on the scanning technology? That's
good point.
Kind of what I've been kind of wondering. And the thing is that leads you to your impact zones, kind of how they're being used. Because then it really depends on what type of lighting that you're scanning in. So if you're scanning in a blue light, you could have problems. You're scanning in a red light, which most like combat zone nighttime lighting is all in red, to preserve your night vision. But some people keep if you have to keep it in that and stuff like that or whatnot, and so it doesn't deteriorate anything. You have bright light, and you have no light, and you have all the other fun stuff. No light's probably gonna be the fun one.
Wow. I mean, it all makes sense to me. I think it also is so the quality of the camera, the quality of the program should be considered as well.
Right.
So in a lot of these cases, like we've talked about everything. Oh, actually, before I get into the programming side, I think I wanted to agree with what you're saying as far as the outside lighting, because that made me think that okay, how can I tell my camera I'm scanning this object in like 2 inches from the screen, or am I scanning the entire area that I'm pointed at. So one thing I did look up a couple reviews of Polycam because I was just curious because I might be in line for an upgrade on a phone and was like, might as well. but
Staying inside the
just a
ecosystem.
little bit of this is the rabbit holes we kind of roll into when we're looking on the internet. We got
Daily.
cool. It's cool stuff, to be honest with you.
Yeah.
And if it could be a part of my I need a phone anyways. If I could task that in with it, I might save a little bit of money instead of buying a different scanner. So that's kind of the mindset of
EDC
it.
3D scanner.
Yeah, but the problem with Polycam when I looked up the reviews was it was picking up everything in the.
So you go there and deselect everything.
So you had to go back and there was some cleaning you had to do. You had to remove background objects. It would still be kind of like a little spiky, but with what Ed's saying, I don't think there's anything right now that I can say. Maybe DALL-E, which is ChatGPT or OpenAI based, I could put in a picture and say, hey, clean this resolution, or put in a file and say, hey, I need you to clean this resolution. But
So
I
in
think-
particular, Mid-Journey is the standard
for that.
for images at the moment.
But isn't it?
So like,
It's my understanding Midjourney is only word prompting. You can't put an image in and say
I don't think
clean
it's
it.
document processing yet.
Yeah, I think,
but I think you can.
but it's upscaling.
Well-
I've used before. It's pretty amazing.
I may be wrong.
But there's Midjourney. Midjourney is
No, I may be wrong. I may be thinking opposite. But even with that, say I can tell Mid-Journey, hey, I need this kind of object, and then whatever the object is, I describe that object. Now I can take that image and compare it to my image, and I can take that image and use it.
So like instead of scanning, you have. I mean, the prompting to me, I've seen someone prompt in, and this is definitely a sidebar. I've seen someone prompt, and I have a friend who uses Midjourney pretty religiously, and I've seen kind of what you can create with just a basic sentence, and let the AI kind of just roam free to kind of predict what you're trying to make.
Express itself.
Or if you write a full paragraph or you prompt it that way, and how precise it could be, even to like the littlest minute detail of having a freckle here, freckle there. Like it's something I've seen very detailed, and I enjoy it too because we did a lot of thought experiments with it. We tried to get it to like write words and like actually form like sentences and things like that. We even tried to put like
word art.
Like breaking
Or clip
news,
art?
like you know how it, in movies, like a newspaper would pop up and say breaking news or whatever, or like your news show.
Yeah.
We wanted something like on the paper that popped up and it just said, "Hey, this is a big deal" or something. Anything in English on there. Never once did it have a single letter that made any sense. It was a bunch of squiggly lines. It looked like web dings.
So it does look like
Never
you can
once.
import images into Mid-Journey.
Okay, yeah, that's something. So they started asking for money. It was free for a little bit, and that's why I kind of stopped
something
because
you can add it to Discord using the button in the message, blah blah blah. But yeah,
Okay.
it's a way to do
Well,
it.
that's another thing. It's like, it's only attached to Discord though. That's what's kind of driving you
is.
nuts.
It is a little bit limited.
I'm just saying, but if you doing this as hey, making my own action figures, and you sculpted the action figure, but you want to change something on this action figure that you sculpt.
Yeah.
But I want to resculpt what I've sculpted. I can take pictures. The way I've seen it be monetized at the moment with the cameras, and of course they're using probably one of $1,000 to $10,000.
Yeah.
So one of the higher end ones, what they're doing is they take and like make a sculpt. From that sculpt, they'll then use that to take a picture of the sculpt, and then that creates a file, so that they don't have to have a
like your
person.
background or something.
Yeah, they don't have to have a person to actually digitally sculpt the item. So they physically sculpt it, but now you want to capture it.
Right.
That's the way I've seen it. Or they try to reverse engineer a product, and they need a STL file of the shell. So they're not trying to recreate the electronics; they're trying to recreate the outer shell.
That's when you start getting to like the Canon R and stuff like that for better cameras and
But
stuff like that.
I'll say this about the cameras: most cameras can correct for even things with taking dark photos. Infrared is better, but there are things you can do. You can do lighting and so forth. Because you're not doing this like, hey, I'm going out to 3D print this person and capture it like I'm a professional photographer. You have a specific use for this tool. It's almost like buying a reader back before they added the diagnostic port to your car to read the codes from the car.
It's,
The
so,
OBD2 reader.
Yeah.
so okay, I kind of backstep, but I did want to kind of get into software though, because I think that no matter we've talked about the specs and the limitations, or the innovations of the technology, like the camera systems and things like that, scanning. We've talked about even how physically things are affected by light waves, because this is you're using light waves. Like you have to think about that. But I think most of our issues that are probably going to be seen is with how there's no doubt in my mind that the cameras are scanning.
Yeah.
There's no doubt. The quality of that could be dependent on the device, but it's really most importantly how your application, which is most of the time proprietary to the brand, interprets that picture or takes those scans.
Yeah. What algorithm they're using?
Because if you can have the best scan, but if the application is absolute garbage, then you're not getting anything out.
Some of the higher end ones already converts it to an SD file.
That's what the
And
one.
the camera.
Yeah, the one that I'm looking at.
So you don't. There is no.
So that's part of why I bring up the software.
The new Revo Point that I picked up. I don't know if you remember the one that we played with, and the handheld scanner that we played with. It's pretty much that, just in a smaller form that does all the STL conversion. Which is the good thing about that. If you're looking at it at the top of the screen, it has a status bar that tells you how good your scan is, and it tells you kind of what your pixel level is. So as long as you stay inside that the good, better, best,
It'll tell you it hates. It's like,
you're
hey, stop-
there.
stop doing what you're doing.
It'll say go back and try again. It'll tell you where you missed. And the thing is the good thing is on like the ones that have a screen built into them, especially like the all-in-one stuff.
Yeah.
You can actually see the cloud as you're scanning. You can see the drawing kind of pop up.
What is it? The render distance.
Yeah, the
like,
render
or something
distance and stuff
that,
like that. You can actually see the image pop up.
Okay.
So you're getting the sense clouds popping up. So it's telling you kind of where you're at and stuff like that. I think it's called sense cloud. But
pretty cool.
so you can actually kind of see everything kind of taking shape.
Yeah.
As you're making the connections across the object. And the funny part is, we think about it. 3D scanning, as far as I kind of touched a little bit on earlier, is you get these guys who walk through collector cars. You guys are still restoring Model Ts.
Yeah.
They're still remodeling redoing Model A's. There's still some on the road that are in pristine condition.
Yeah.
However, last time I checked, I can't go to the AutoZone and go pick up a part for a Model A.
No, you're not gonna.
Or a Model T or a hot rod. Sometimes if something breaks, you can scan it and rebuild it, and just do it out of a 3D print before you send off to Geometry or something like that, and have them rip it out of freaking steel or whatnot. If you don't have a CNC machine of your own.
Right.
You can also do R&D parts. Scan the entire vehicle, print the entire vehicle out on a resin printer, and be able to adjust stuff that you want, so you can actually see it in like 1/8 scale.
Yeah, I mean we've seen examples of where they're like, hey, we have a problem with weight, or we have a problem with aerodynamics. We need to how can we best design this, and then make 4 or 5 designs and run them through air testing. So you test everything. I mean we've even seen STLs loaded into other programs like SolidWorks, and they run a efficiency test on if this was like a pipe for airflow or whatever it said.
The fluid dynamics.
Or if you're it's like you have a bunch of energy at the top that's getting pushed by the fan, but you're losing all your energy before you get to the exit. Things like that. I mean, at the end of the day, the software. I don't want to say the software is a limitation, because to me the hardware is one of the biggest limitations, because if you don't have a way to sense what the object, then you're out anyways. You're gonna design it, and it's all waste anyways. But if you have good software, or if you have good like AI or some type of like image generation. I mean, right now, what is it? OpenAI is doing videos, like 3D videos, where they're saying, hey, you can input a video and say, hey, make it this, or you can even prompt it like you do Midjourney and say, what was it? A video of the mammoths that I saw.
Yeah, Picture AI does that too, and it will take an entire script and do a voiceover video.
So there's no doubt that the innovation's coming.
Yeah,
I mean,
the thing is I think some of it also goes to the price point. You know, you got guys who are, you know, spending, you know, upwards, you know, they're like, you know, for like we said, $400 or $500, $200, $300.
Yeah.
There's some of these companies up to, you know, $900 to I think it was what $1,485 that
It
I
gets
spent.
expensive.
A
Yeah.
1,000 to 10,000
And
is
then-
considered.
Yeah. Then you have your 10,000 plus machines, and then you have some of the ones that go on the end of Faro arms are what $100 grand, you know, roughly about $100 grand if you want the one that's on the end of a Faro arm, and that's pretty much your top of the line. But the thing is, you got to run a darn server for it to actually just process anything.
No, actually, we use them at the plant, and they use it on a PC.
Yeah, but it's the size of a server.
No.
We spec them out. We don't
No. We actually use them in the gun shop with a regular PC.
on a laptop.
Yes.
Oh, okay.
Oh wow.
I know we do have some of the server ones back there.
I mean, but you, so
The one
one
in
is,
that- the-
one is doing guns, the other people are doing tooling.
Yeah.
So you're talking two different applications.
Right.
Tooling is what you're talking
Right.
about. You have to have either the PC that's the equivalent to a server, or a laptop that's equivalent to a server, or you have to have a server.
Right.
But if I'm measuring a gun is totally different from what I'm measuring. You know, measuring what's closing on the gun.
Yeah, and you know you got the guys from like for example SEMA Garage in Detroit and also out in California. You know they have 3D scanning and 3D printing, you know sectors inside the SEMA Garage. It's open to members and stuff like that, and they do everything with a Faro. All their scanning is done with Faro arm. Or so like you know they catalog all these vehicles and they scan them and stuff like that and throw them into the CAD files for members to you know to play with.
That'd be cool.
But they use an entire Faro arm.
That'd be a fun job.
And this is not new technology. It's been around since 1960.
Oh yeah.
It's just much cheaper now.
No, well, it is cheaper, but what's new is portable.
Oh, okay.
The portable is the only new part.
Okay.
Well, not excuse me. The portable is the part that intriguing to people that's in the 3D printing industry. The advances in the cameras, you know, how precise we can get with lenses or not have lenses.
Yeah.
You know, how precise we are with microcontrollers or chips. The chips are a lot, you know, more advanced now. So yes, that has advanced, but the technology is from around the 60s.
Yeah.
Okay. Yeah. No. I mean, I figured as much.
Laser.
Yeah. Yeah. I mean, lasers, man. We what was it? The double slit experiments where they started even like first thinking about like even lasers and how they act as particles and also as waves. So I mean, light in and of itself, we could talk about probably for like nonstop. I mean, it's the speed of the universe, the upper limit of the universe, as fast as it goes. So for me, I mean, light's already fascinating. So using this to be able to make a structure and then put it to use in the additive manufacturing world, that's fascinating to me. I don't know. I would want to keep scanning everything in my house.
Just don't scan the cat. Well, good scan the cat.
I'm gonna scan.
If
I'm gonna scan the cats.
The cat stays still.
Oh, his cats will.
They sleep. They'll be fine.
But you know, hey, maybe you can scan parts and figure out why the Voron doesn't work.
Oh, I know why it doesn't work.
But you know, the thing is you know, like you said, I think the you know the 3D scanners attached to the additive manufacturing world is a game changer. A 3D, and you know we use that term very very lightly. You know, a 3D scanner attached to a robot arm. You know, that is you know next generation cool. You know, you got these guys who are you know you spend all day long scanning parts by hand. You know, throw a damn thing on the end of a KUKA arm, let it rip.
And remember, he said one of the application they were using for was checks.
Yeah.
It was used as a quality gate.
Yep.
The scanner itself.
Yes,
Yeah.
Oh,
because
okay.
once you scan the part in, now you have that data.
Now you know. If
And
it's
when
not
each
complete.
part come by, when we talking
Yeah.
CNC, like pulling out a machine,
Okay.
you can set up, because you can do it with cameras or you can do it with a handheld. And these cameras could be positioned in such a way to scan the part, and that was your quality control.
Yep. And they compare it to a known good image. So you take a known good image and you put it,
makes
and it picks it out, checks it, puts it back. Picks it out, checks it, puts it back. And it's like 30 seconds. But
Yeah.
then you have the ones that they'll take it and set it inside of a fixture, and they'll spin a robot arm around it, like a mini KUKA arm.
Yeah.
I can't remember the model number, but
They had a few. I mean, you could either spin
Yeah.
the part, and for me, it's probably easier to rotate the part
Right.
and just have the robot adjust.
Yeah, and I think that's what they were
Yeah.
doing. They were doing the spin with a robot, getting as far as they can, and then moved it.
Mm-hmm.
But and the thing is, and that's all from Zeiss. You think about Zeiss's scanners start. I think they started low. They were like $5,000, I think. I'm saying low, but that's for a Zeiss scanner. That's pretty low.
We're in that's industrial like that.
Right.
We're not talking like
But if
consumers.
you're an
Yeah.
automotive company
Yeah.
and you have a measurement shop, that's another tool
Well-
you can use inside your measurement shop.
Think about this.
It's
You-
true.
And the one thing is,
You don't have to go measure all day.
is you got these guys doing paint and body and dent repair and stuff like that.
Yeah.
I can take a 3D scanner and run down the side of a vehicle with it. I can show you all your dents because it's going to pop in the image. As soon as you throw that thing up into a 3D image,
Yeah.
you can see where those dents are.
Well, that's what I was
They
gonna say.
may be invisible to the human eye at the moment.
That's why we have a light tunnel. That's why
Yeah.
light tunnels are used whenever people are doing dent repair or like
Mm-hmm.
or paint repair. Because if you put that light there, you start to see how it gets bent over that dent. And if you could see, that's the only way that I would see any dents in some cars.
Now, there are light tunnels per se out there because we kind of looked at a few of them and a couple places already have them that we know of. That when a vehicle runs through, it's a set of cameras that wraps around the entire vehicle and it scans the vehicle as it runs through with no human interaction. It scans all the way through
Yep.
and immediately starts alerting the operator that, hey, guess what, you got a dent here because a light reflected in a certain area. It didn't like it, and it shows you a scan up on the window, up on the TV. It says, "Okay, cool, you're good," or "Hey, there's a spot here, and spot here." And it automatically does auto dent connection.
Yeah,
And
yeah.
you can thank Hollywood for
Right,
that technology.
but and the
Yeah.
thing is this is kind of
That's what they do on some of the things when they're trying to get certain shots.
and it gets kind of weird when you start talking about the fact that you can actually do it with a Raspberry Pi. You can hook up a Raspberry Pi 5 or 4 for that matter with a bunch of cameras wrapped around a vehicle, right? And then you can use AI, you can use image processing. So as the vehicle is running through, it's looking, and then you have that compared to a known dent system that tells you kind of what a dent kind of looks like, and it'll alert you to certain locations.
Yeah.
And then you write the program, which I've kind of seen a program written on it, where where there's a picture of a van, or there's a picture of a vehicle, and it shows you where the dents are at.
Yeah.
And they're saying that if you train the model correctly, it's got about a 90% chance of being accurate. And that's off of a El Cheapo Raspberry Pi and a Raspberry Pi camera. Or multiple Raspberry Pi
I'm
cameras.
gonna be honest with you. The Raspberry Pi camera is a little bit low quality. It's
Yeah.
got it's only like 12
Right.
megapixels.
But the thing is anything's possible. Now, if you start adding 3D scanning to that,
yeah.
now you can even tell if a bolt's loose.
Yeah, that's one of the things too. I think we've talked about before is like validation and quality checks. Like we're thinking about the scan. We started this thinking about scanning is the starting process, the most important piece, because then the printing is only secondary. We're already established. We can do printing. We're talking about adding the scanning to that. But like if you can continue that entire process together and then not only at the end finish a product and have it quote unquote as perfect as you can get it, you're checking for the quality defects at the end of it too. So if you're able to get any of those artifacts or any of those dents or any of those scratches, honestly, we would prefer them not to happen, but they
Yeah,
happen.
things
I mean,
happen.
It's life. Things happen. So how do we deal with those things? And from that point on, we probably could have something that's automated that repairs those dents. Right now, probably not. It's too
Right.
custom. But we have reworkers for those things now. So, I mean, you can even take that into we were talking about the boltings and things like that. Like, what about like airplanes and aeronautics? Like, they even have to go through vibration testing too.
Yep.
So like, while you're vibration testing, you're scanning too, so you can check to see if there's any distortion in the wing shape or anything unexpected. So there's a whole bunch of things that you could use, but scanning needs to be implemented. I want to say more often.
That's quality check. Yeah.
I mean, we scan a lot of stuff, but like whenever I'm asked about what people are scanning, they're scanning barcodes to get information. They're scanning a QR code to get the menu at a bar or something like that. So if we're scanning 3D objects, we're able to put them in any type of world. We're making digital worlds already. that's cool. I mean, think about game developers.
Mhm.
Like, if I'm like, I want to put my house in this game. I mean, you need an expensive scanner, but like
Yeah.
you can still scan. You can probably do piecemeal and scan part by part and get the rest of the house in there. So
Right.
I think that
I mean-
it's going to be used everywhere.
Yeah. Far as the house, like I think that could be done with a regular camera.
Oh yeah,
And the reason I say it can be done with a regular camera is because you can just do a picture roll.
right.
That's
It's
generally
a bigger object at
But
this point too.
now, look, but that's good that you said that. That's the old way to do it. Now, the housing industry is using that scanner technology to
Oh,
come
yeah?
in and scan the rooms.
Oh yeah,
And
yeah.
they build these models that they can use online
people
for a
can
person
see 'em
can
online,
actually
yeah.
walk into it. One thing I would want to point out that if you can get at most of the better cameras have a range accuracy wise of 0.1 millimeter or better.
Okay.
That's considered a professional application of the
to the point, like
0.1 millimeter,
okay,
and that's the structured light scanners.
okay.
But I think the point of us, having the conversation about the laser scanner was from a point. Okay, hey, I want to build an action figure. So how do I build this action figure? I don't have a model. I'm not a guy that's a 3D modeler or a CAD CAM guy, but I have this action figure. I want to scan this action figure to see how it's made. Now I can take this action figure and scan it and put it in a model and pull it apart. Oh, okay, this is how this connects. And then you can go from there to, okay, now I can build mine because I want to use this type of connection for this type of action figure. What I'm seeing is being used a lot in people that are making statues or like making replicas of statues from like small statues. They're scaling them up to a larger size. Or people are making their own bobbleheads. They're making their own like tabletop. They could scan a whole thing of say miniatures, and then they can change them around easier. So I'm seeing that kind of application. It's a little expensive to do that. I would say the professionals are using it the way you said, using it for some kind of quality control, or they're using it to
Rapid prototyping.
re-engineer something. Hey, this is not being created anymore. I need a model of this to get it into a program so that I can, either remake it, or hey, this is a good product. I need it, but I need it to fit the object I'm trying to put it on. So I have to change it, but I want it to be structurally different.
Structurally alive, yeah.
Yeah, I want it to be stronger. In the way to make it stronger, I have to do a different material or a different shape, but I need for it to fit on this object.
The rapid prototyping and the speed of delivery that you start dealing with when you start dealing with 3D scanning and 3D printing and
Just the sheer reverse
everything
engineering,
thrown into one is kind of where you hit that the specialty market, and the thing is, and that's where it's kind of like you have manufacturers out there that need to capitalize on stuff. Where you have 3D scanning, you take it in 3D scan and send it over to a 3D printer and go from there. And the thing is, that's where you kind of laugh, because you got some of these guys out there who are building, and I since I like cars, I bring it up for them at their standpoint, is the fact that you got guys who are making custom hot rods who are utilizing 3D scanning and 3D printing faster, better, and more efficiently than the guys who are, building full-blown cars, as far as, manufacturers. I watched somebody, they built, I think it was a 4-rotor or an 8-rotor freaking RX motor the other day. And because he wanted to see how things worked, he scanned the top of the motor to get the port sizes and then built an intake in CAD and 3D printed the darn thing to make sure it fit, make sure everything was right, and then sent it over to a CNC machine and took these 12-pound blocks of aluminum down to 2.5 pounds, and all was just 3D scanning and 3D printing and, taking all that and sending it back to, a CNC machine to complete the complete process.
I mean, that makes sense. You're using that advanced subtractive to get to the end goal. I think we were it's probably been months by this point, but we saw an article as well. I can't remember what branch. I think it was the Army that was using this, but it could have been the Air Force because they were flying. Like,
Oh, that was the Marine Corps that was doing the splints. It was the Navy and the
No. There was a part. There was a plane, like a couple million dollar plane that's going to get decommissioned because this part.
Oh, that was the Air Force. Yeah, the Air Force was that.
So there was a part that no one manufactures. The tooling is not there anymore. No one creates it. No company is going to support this. So he took it, and I don't think he did a scan, but he reverse engineered it somehow with 3D printing and rapid prototyping. But how much easier would his life would have been if he just was able to take that part, scan it off of one that's working, and then come back over and print that piece. You're done. You don't need to mass produce 20, 40, 30 of these things. Yeah. You have one working? All right, let's copy off the one working.
It was off the B-52. The B-52 was what did it. And the thing is as the FAA approves more and more and more uses of 3D printing, which they have not yet.
I think they will, though. Like
they're getting around to it. They're working on it. I know it's on the docket for this year for them to look at. You're going to see more and more 3D scanning come up.
Think about what NASA's doing.
Because you got the guys who are building structural parts. Yeah. They need to scan that structural part amount and freaking go from there. Especially you guys got building like aileron joints and stuff like that. They need to scan parts from like a decommissioned aircraft to create them. Or the guys who are building kit planes. Mm-hmm. And the guys building kit planes, they're dumping all this money into kit planes, and they could turn when they build them out finally, after 15 or so years of owning them. Then they can easily go back and, reverse engineer what they need based off, known good points.
Yeah, and I can see some of that based on we don't know. We may not have enough data right now to know what the stresses are on, say, something that's 3D printed in some application as opposed to something that's been subtractive, machined.
Yeah, I think.
So it's probably there.
Yeah.
As the metal side of additive grows.
I think that's where that Haas CNC machine with Weld.io kind of steps in and kind of bridges that gap.
It's going to be a mixture.
They got to have more data.
Yeah, it's going to be a mixture of the two. Like honestly, these things are probably going to form or like connect into some point and be one machine because like at a certain point, subtractive, additive. It depends on the situation that you're in, and if you have the materials on site, you can always do additive.
Right.
But the problem with additive is if you add too much, then you're stuck. So then comes subtractive.
Unless we're using metal and it's machinable.
That's true.
That's why I said metal is the key.
Yeah.
They once they figure that out, get it to where it's a process that can be repeated. Yeah. There's no special things you have to do. Mm-hmm. I can use all type of materials, Inconel, copper. Like right now, copper is something they're working on because of welding and copper. Because of the reflective nature of it. But when we're talking lasers, we're talking lasers when we're saying this. I'm sorry. So somebody will say, "What do you mean?" We're speaking about lasers. Yeah. But I'm saying once they can work out the metal part. It's no problem.
Yeah.
If you think about it,
there's your durability right there.
Like Daniel Defense, for example, down in Savannah, firearms manufacturer, they have taken the 3D printing thing by storm there for a while because they're making 3D printed Inconel suppressors. That was mass marketed, and they're highly reliable. They're more reliable than some of the other ones that were out there.
I think that would be most people's worries is reliability or consistency.
And the thing is they're full auto rated.
Yeah.
They actually hooked them up on the end of a machine gun and tested them that way just to make sure that, hey, guess what, we're not lying here. Because it's Inconel. Mm-hmm. But the thing is they even said in one of the interviews they did, they took, 3D scanning of a suppressor they've already made and said, okay, cool, how do we make this thing better? We know the weight, we know what it is, we know and that's how they also used it to compare against, what they were printing, because they were talking about how, and the thing is, a lot of other people talk about the same thing, that you can get tables, with screens on them, put them on there, it's the same exact size what you need to do. So as soon as you print it, you sit down on top of the table, and it's 3D printed, it's 3D scanned.
Yeah.
And a lot of them use the tables, either single axis or multi-axis.
Yeah.
As
And
far as manipulating
Right.
the part. If we're talking just scanning.
Right. And if you think about it, we all talk about, hey, we're eventually going to get to the world of, the MCU, where everybody wants to be an Iron Man, or, thinks they can be Iron Man. That's going to be a fun world. But, you have scanners there that are available that people can easily scan what they're building, print it, and compare it to the scan and say, okay, cool, I can rapid prototype this, to grow their businesses faster.
Yeah.
I mean, but when you go through a scanner in the airport, same concept.
Yeah.
I can remember when you was talking to people, talking about taking a scan of you so you could be, you could get
Yeah, we're still waiting on that.
Yes,
Thanks
sir.
for your
the
point.
concept.
Yeah, actually.
The proof of concept is there.
Yeah.
There's a device you already go stand in, you stay in a position and it scans.
Yeah, there was one in
Yeah.
Vegas or something like that where they.
No, I mean like every airport
Yeah.
No,
that
I
you
know.
go through.
Yeah.
But yeah, put this technology. But here's the thing that I'm gonna go one step further. X-ray 3D scanning.
You see through the object?
Maybe I need to see what's inside of this object.
Yeah, CT scan.
Yeah, that's a CT scanner, but
But but I'm saying,
but
maybe actually you say that Adam Savage actually used an application where it did that, and it showed the inside of this object.
I think
And
there's
they-
a big machine that we were looking
Yes.
at too. Yeah, I think
Yes.
I watched that video.
This is a function now that people are using to understand what's happening inside something without cutting it open.
yeah, I've seen that.
That was the
Yeah.
thing. Because like right now, currently, how we investigate stuff is we cut it open, we break it apart, see what the inside does, and so next time we know what to do. With that, sacrifices the first example. So yeah, it's a problem. I mean, a CT scan, it's kind of a scary machine once you like take off the cover and see what's actually happening.
Yeah, I mean,
But at the end of the day, it's using the same idea of like the scanner is shooting you like X-rays. It's a different wavelength instead of a visible wavelength, and it's getting through and terminating in a certain place to see inside you.
Right.
Yeah.
That right there.
and I mean it's for objects,
Yeah.
not humans.
Because
We don't have to do it for humans because we've already mutilated humans
Yeah.
hundreds of years ago, and we know what the inside of humans look
and
like.
we
we
it's
got the
like,
whole gene.
And there is a machine for that already.
yeah,
Yeah.
They got what now? They can do like
Well-
where wives can go see the 3D baby whenever they want to see it coming.
The
yeah.
the sonograms,
wow.
yeah.
Sonograms, 3D
think about
sonograms.
Now they can even tell bone density.
Yeah.
Wow.
And so, next thing you know, people are going to be now 3D printing their
Like this was
Hey.
you before you were born.
Yeah.
Right.
Hey, that's a thing.
I'm
But
not sure how far back they want to go on that one, but
Nostalgia.
it can get kind of interesting.
for me, this is where I find it like, hey, this would be cool to do this. Okay, I have an image of this apparatus that was built back in the 20s. I want to build a replica of that. Well, I only have this photo, but there is one in the museum.
Scan it.
You reach out to the museum and say, hey, I want to do a scan of this so I can make a replica of this. And then you can build that replica.
Yep.
I mean, that's where you start to see
Yeah.
applications. Or, hey, I have, like you said, this rocket or this
It's archival investigation.
yeah.
And because the thing is, if you think about it, and I know we're kind of running along on timer. If you think about it, if you're scanning something and you save that STL, you're preserving history.
Yeah.
You're preserving history at that time.
Especially if it's in the third dimension.
Right. And the thing is it's kind of like 3D archiving. It's digital
Yeah,
archiving
that'd be-
in a different fashion. And for me, that's amazing. You talk about you go to some of these museums who have so much stuff in the archives, and the backside of the archives that's just sitting there. Slowly but sure, and archival boxes and stuff like that.
And it's degrading
Right.
over the years. So you're eventually going to lose that specimen.
Right. And it's like, the Smithsonian, they do a really good job, I think, of scanning some things, but not everything.
Yeah.
And, you're talking about, you have pieces, inside their collections that are just absolutely priceless. You have things that are, and through like some of the other, museums, it's absolutely, you can never reproduce that again. The Mercedes-Benz Museum, for example, in Stuttgart, they have the first ever automobile, that was done by Carl Benz. The thing is, eventually that thing's going to start falling apart. I know they take care of it. I know they take care of it really well. If you start scanning that into a process, now you have that as an archive. So if something ever does happen to it, you can show kids, hey, this is what it was. It may not be in color, unless you have a full-blown, full color, like RGB 3D scanner, which most of them now, if you have the handheld ones, are RGB and are color scanners. And so you have all of this that you can put up on boards so people can look at, spin around, and touch.
I mean, another way to look at it is I can take those 3D images, I can put them into, some software where I can, like it's archive. Now I can make that work with augmented reality.
Right.
And then maybe that conversation I had with my grandfather that I was sitting there scanning us with the interaction, I could either play it back or via VR and augmentation. I could have a conversation with my grandfather about the moment that we remembered. Because that memory would be captured of us having that conversation.
And if you think about it, even if you're doing like 3D archiving, which is actually a pretty interesting topic, and you scan these things, you put them up in a in a lift platform, so like kind of like in a 3D environment where you can spin it around by fingers. Spin it in the air, like how you're talking about VR, but you have it like on a screen, so everybody can see it. You can zoom in on it, look at it. But the thing is, most people learn via touch. Most people learn by, let me touch that, let me investigate that, let me dig in a little bit deeper to that. But most museums don't allow kids to go touchy-feely on things.
Yeah.
They want to zoom in and see, okay, cool, that's what that looks like. That's what that connector was. And especially you start talking about spacesuits, you only see so much through glass. Why can't I, scan a spacesuit and zoom in on it and say, okay, cool, so that's what that connector is. That's what that means. That's what was on his badge.
And like I said, a lot of what I've seen, like say, I don't know how much of Adam Savage show you watch, but he's done several spacesuits.
Yeah.
And he does a lot of his from photographs.
Right.
Or from screenshots from video.
Yeah.
So imagine how much time he would have been able to save if he was able to scan that suit. I don't want to touch it. Or you guys make a scan of this and just make it available like NASA makes files and software
They
available.
got a repository for a lot of the ships and stuff.
Yeah, you have the 3D archiving.
I think I'm gonna try to print the Parker Solar Probe next.
Nice.
Yeah, it'll be looking nice. You guys should check out the NASA repository.
Yeah, it's pretty cool. They have Voyager on there too, I think. Recently. So, I think that will do us for tonight. We want to say thank you to everybody who's kind of tuned in, listened to us ramble. We also want to thank, how many, thank every single one of y'all who have taken time, to look at us on different platforms and stuff like that, kind of follow along what we're doing. And we hope that, once we get the 3D scanner, we can do a lot more with it, a little bit more fun with it, stuff like that. Really kind of experiment with it a little bit more, and kind of push it to its limits. That's and the thing is we want to learn as much as you do, and we want to make sure that you learn as much as we do. We're up to 2230 on total downloads. A couple months ago we were fighting to go to 2,000. So. I just want to say thank you again. Go take a look at, all the socials. Go take a look at, Printed Heritage, Vulcan R3D for shirts. We got to get more of those made. And then, a couple other things, that we got going on the blog. We will be updating our website soon. I'm going to be transferring that over to AWS. So, if that goes down for a second, don't bite me. So, we're working through that. If you are going to be at, Automate this year, let us know. We'll definitely meet up with you to have a conversation. And then there is a chance, pending on how things go, myself, one of our other guys, will be possibly out at SEMA in November this year for the annual SEMA show, kind of walking around and seeing things. So, I want to say thank you. We appreciate you. And, I'll turn it over to the guys. Y'all have a good one.
I just like to say I appreciate all of the support, appreciate the listeners. We're still open to any suggestions you guys have, topics that you would like us to touch on, or we're still trying to figure out the logistics for doing a live feed. Maybe you guys have a time that works for everyone, or maybe we'll do a couple of different live feeds at different times. But we'd like to get your input on that, and like I said, we appreciate your support.
Yeah, it's same thing for me, guys. It's always appreciative, just being able to chat on a platform. I'll kind of repeat what I said a couple weeks ago. If you haven't checked out any scholarly articles, that's kind of where a lot of the information that I would kind of try to commit to knowledge. It's coming from those articles. I'm not just trying to go on YouTube or Google and type in something. Whereas you can do that, you might find some good information. You should really supplement that with some of the scholarly articles, because then you get to see it from the side of an engineer, scientist who has a much more intimate knowledge of that subject. So check out some of those free websites. Look at some of our stuff. We might even be able to put a link. You might find, I don't know if Nick, you posted your scholarly article.
Well, it never got actually published because I said it wasn't inside the realm of knowledge. So.
Well,
But I will post
eventually.
the PDF document of it.
Yeah.
For the digital transformation stuff, looking at a couple of the rocket companies and stuff like that.
Yeah.
And the thing is I know that things will be embargoed, eventually. But I'm going to take you all along on the fun ride that is going to be the dissertation process for school, coming up soon through the doctoral program. So we'll be bringing you along on that. I think I got a couple ideas what I might do for my research. So the thing is, it might involve some of y'all, listening on what we're doing and stuff like that. So.
Yeah. But yeah, no, guys, keep on listening. Stay tuned to the podcast, the blog posts. Check out the website, everything. And if you've got anything you want us to chat about or any questions, just reach out. All right, guys.
All right, y'all. Have a good one.
Bye.
That's all for this episode of Tech at Lunch. Thanks for tuning in and joining us for this tech-filled lunch break. We hope you enjoy the show, and don't forget to subscribe on all channels. And also, you can find us on YouTube under Vulcanar Technology Solutions. And join us for our next episode, which gets published every Wednesday at 8 a.m. All right, y'all. Have a good one. See you later.